Chalo dosto, welcome. Today we are going to tackle a chapter that sounds a little scary, doesn't it? Atoms and molecules. But I promise you, by the end of this session, you'll feel like it's the easiest thing ever. We are literally going to unlock the secret code of the entire universe. So are you ready? Let's go.
Okay, just look at your screen for a second. What do you think this is? Some kind of modern art? A cool new wallpaper? Well, what if I told you this is the surface of silicon, zoomed in millions and millions of times? And what if I told you that you, your phone, the chair you're sitting on, even the entire universe is made of these tiny, tiny things? It's mind-blowing, right? So this leads us to a really big question. Think about it. When a mason builds a huge house, what's the one basic thing he starts with? Bricks, right? He takes one brick, then another, and soon you have a wall, rooms, and a whole building. So the question is, what are the bricks of our universe? What's the most basic thing that everything, and I mean everything, is made of? This isn't some new age scientific discovery. Nope. Way back, around 500 BC, an ancient Indian philosopher and sage, Maharishi Kanad, had this exact same thought. He said, hey, if you take any matter, any padarth, and you just keep dividing it, cutting it smaller and smaller and smaller, you'll eventually get to a particle so tiny it cannot be divided anymore. And he gave it a name. He called it permano. Isn't that just incredible? This idea has been with us for thousands of years. Now, I know what you might be thinking. Sir, this is all very interesting, but why should I care? It's something so small I can't even see it. And that is an excellent question, Beta. Here's the answer. Understanding atoms is like getting the secret recipe book for the whole world. It's the why behind everything. Why is water wet? Why does iron get rusty? How does the battery in your phone actually work? This chapter, it's the key that unlocks all those secrets.
All right, so before we jump right into the atom itself, we need to learn the two golden rules of the game. These are the two unbreakable laws that atoms always follow, no exceptions. You can think of them as the constitution of chemistry. And these rules were laid down by the great scientist Anton Lavoisier. He's basically the father of modern chemistry.
And here they are, the two big bosses. On one side, we have the law of conservation of mass, and on the other, the law of constant proportions. Now, I know the names sound heavy and complicated, but trust me, the ideas behind them are super, super simple. Let's check them out. Okay, rule number 1, law of conservation of mass. What does it mean? Basically, you can't create matter from nothing and you can't destroy it. It just changes its form. It's like a costume change. Imagine this. You take 10 kilograms of wood and you burn it. Poof! It turns into ash and smoke. You might think the mass is gone, right? Wrong. If you could somehow catch all that smoke, all the gases, and collect all the ash and weigh it all, guess what? It would weigh exactly 10 kilograms. Nothing is ever lost.
And now for rule number 2. The law of constant proportions. This one is also really simple, but so important. It just says that a chemical compound is like a perfect recipe. It doesn't matter who makes it or where you get it from, the ingredients are always in the same fixed proportion by mass. It's just like making a cake. You always need a specific amount of flour, sugar, and eggs, right? If you change that ratio, it's not the same cake anymore. Chemistry works just like that.
And the best example for this is water. H2O. Now, you can take water from a river, you can get it from the rain, you can get it from your water bottle, it does not matter. The recipe is always the same. For every 1 gram of hydrogen, you will always find 8 grams of oxygen. That 1:8 ratio by mass is fixed. It's a universal rule. That's the law of constant proportions in action. Okay, so let's recap. We have these ancient ideas about parmanu, and we have these two golden rules of chemistry. But who was the genius who connected all the dots? Well, it's time to introduce the hero of our story, a British chemist named John Dalton. He's the guy who took all these ideas and created one powerful theory, the first proper scientific theory of the atom. And there he is, the man himself, John Dalton. And here's an amazing fact about him. He came from a poor family and started working as a teacher when he was only 12 years old. Can you even imagine that? He was a brilliant mind who, in 1808, gave us the theory that completely changed the way we look at matter. So what exactly did Dalton say? His ideas were so simple you can think of them like Lego blocks. Seriously. First he said all matter is made of tiny particles called atoms. are Lego blocks. Second, these atoms are indivisible and indestructible. You can't break them or destroy them. See? That's the law of conservation of mass right there. Third, he said atoms of the same element are identical. So all oxygen atoms are like identical red Lego blocks, while all hydrogen atoms are like identical blue Lego blocks. And fourth, atoms combine in simple whole number ratios to form compounds. Like you take one blue block and two red blocks to make something. That explains the law of constant proportions. It all just clicks into place, doesn't it? All right, so we know the rules of the game, but how do these atoms actually connect? How do they hold hands and stick together to make all the stuff we see around us? This is where we learn about their secret handshake. And once we understand that, we can learn to write chemical formulas, which is pretty much the secret language of chemists. To understand this handshake, you need to know one simple word: valency. Don't let the word scare you. It's so easy. Valency is just the combining power of an element. The simplest way to think of it is it's the number of hands an atom has. That's it. Some atoms have one hand, some have two hands, some have three, and they use these hands to hold on to other atoms. And to make this crystal clear, let's play a little game. Imagine we have an octopus. Let's call it O. How many arms does an octopus have? 8, right? So its combining power, or its number of hands, is 8. Now imagine a few humans. We'll call them H. How many arms do we humans have? 2. So our number of hands is 2.
Okay, so the octopus wants to hold hands with the humans. It wants to use all 8 of its arms, and each human has to use both of their arms. So how many humans can one octopus hold? Let's do the math. The octopus has 8 arms. Each human has 2. So 8 divided by 2 is 4, exactly. One octopus can hold hands with 4 humans. So what would the formula be? It would be OH4. OH4. That little 4 at the bottom tells you that you need 4 humans for one octopus. That, my friends, is exactly how chemical formulas work.
Okay, so let's use this for real chemistry now. It's a super easy trick called the crisscross method. Let's try to write the formula for hydrogen chloride. Step 1. Write the symbols. So we write H for hydrogen and Cl for chlorine. Step 2. Write their valency, their number of hands, right on top. Hydrogen's valency is 1 and chlorine's is also 1. Step 3. Now for the magic. Crisscross. The number on top of H goes to the bottom of Cl, and the number on top of Cl goes to the bottom of H. So you get H1Cl1. But in chemistry, we're a bit lazy. We don't write the number 1. So the final formula is just HCl. See? Super simple.
Now, don't get scared by this table. This just shows you the valencies for some common elements. Please, please do not try to memorize it all right now. That's not the point. Just look at it. You can see sodium, Na, has a valency of 1. Oxygen, O, has a valency of 2. Think of this as your cheat sheet. As you do more and more practice, these will become second nature to you. I promise. Whoa, okay, that was a lot of information, but you guys have been absolutely brilliant. So before we wrap this up, let's do a super fast, high-energy revision to lock all these amazing ideas into our brains. Are you ready for it? Let's do this. All right, quickfire round, revise with me, let's go. Everything is made of tiny particles called atoms, yes. Rule number 1, mass is always conserved. It can't be created or destroyed. Rule number 2, compounds always have a fixed recipe or constant proportions. Who gave us the first rulebook for atoms? John Dalton, perfect. And what do we call the combining power or the number of hands of an atom? Valency, fantastic. You guys have nailed it. And now it is time for your final challenge, the Dhammaka question. Are you ready? Using the crisscross method we just learned, I want you to tell me, what is the chemical formula for sodium oxide? Here's your hint. The valency of sodium is 1, and the valency of oxygen is 2. Do the crisscross, figure it out, and type your answer in the comment section below. I will be reading your answers. Amazing work today, everyone. I'll see you in the next one.